Okay, last time we left off, we were talking about qualitative measurements or categorical variables. These are variables that categorize or describe or name some outcome. This should be something like color, right? The blue team, the yellow team. Next, we have quantitative or numerical variables. So a variable that quantifies an element of the population. This will consist of numbers that are measurements or counts. If a variable that has numeric measurements for which operations such as addition or average make sense, right? So if something is quantitative, they are numbers, but unlike qualitative, these numbers actually have some sort of numerical meaning, right? So player 42 was categorical or qualitative because it was just a label, right? It doesn't mean that he's better or worse than player 27. Quantitative variables, the numbers have actual numeric meaning, meaning I could actually say 76 degrees Fahrenheit is warmer than 72 degrees Fahrenheit. This could be things like GPA, age, tuition fees, things like that, right? So you could say a 4.0 GPA is a higher GPA than a 3.2. You could say that someone who is 40 is twice as old as someone who is 20. You could say that if tuition fees at one university are $7,000 a semester and $14,000 another semester, you could say it cost half as much to go to this university. Or I could go to this university for 2 years for the cost of going to that one for one. They have numeric meaning that actually means something in terms of the numbers. Qualitative data can actually be classified in two ways. The first is discrete variables that can be characterized by gaps or interruptions in the values that they can assume. So this would be something like counting data, right? 0, 1, 2, 3, 4. So something like this. You have 0, 1, 2, 3, 4, 5, 6. Something like this. This would represent discrete data, where in between, there's nothing between these two values, meaning that you were either 0 or you were 1, right? So this would be something like, if I'm counting how many cars drive into the parking deck, this would be discrete data. It is either one car or it is two cars. It is two cars or it is three cars. You can't have 0.76 cars. That doesn't make any sense. Same thing with people, right? If I'm saying how many students are in my class this summer, well, the answer could be 35, it could be 72, it could be 74, it could be 976. But in the end, I can't have partial people. It is either one person or it is two people, or it is three people, or it is four people. So these gaps imply an absence between the values. Note, generally discrete values are whole numbers, but they do not have to be whole numbers. So for example, if I am measuring someone's temperature and I'm using a thermometer that has 0.1 decimal point, so that means that it goes from 71 degrees Fahrenheit to 71.1, 71.2, 71.3. Those have a specific gap based on the tool of 0.1, meaning that there will always be a gap. Your temperature can be 71.1 or it can be 71.2. It cannot be 71.176.839, anything like that. So while temperature is generally viewed as what's called continuous, your tool may in fact make it discrete, and in this case it has discrete gaps of 0.1. Discrete values are generally finite, but can be countably infinite. So one thing is, generally when we have discrete data, because we're doing counts, they are finite, meaning that they have some endpoint, right? If I'm counting how many cars go into the USF parking garage, there is a set number of places. There is a set point where I will not have any more cars come in. Where technically though, discrete data can go on forever. 1, 2, 3, 4. This could be something like population in the US or population around the world. Well, so far we've had no stop. Now, is there a certain point where it's going to eventually reach a point where it has to stop? Maybe, but currently it goes on, right? The population, every time we're like, oh, we're as big as it's going to get, it gets bigger, right? So countably infinite just means that it is countable, but it could go off towards infinity, right? So you can have countably infinite discrete values. So that's why what I was saying, be careful when we're talking about finite versus infinite, because oftentimes we think finite, we think discrete data, meaning it has gaps and it can be counted, but you can have discrete data that is also infinite, which means it's countably infinite. An example of variable type would be, this table shows partial list of vulnerable, endangered, and critically endangered species and the approximate number of each species that's remaining. So in this case, what type of data is our qualitative data? Well, that would be our species, right? Because that's a label. If something is labeled as a lion or an elephant, right? If I get a new animal, I can say, what species is this? And I can classify it as one or the other. The quantitative data is the count. How many of that species are there, that endangered species? So it's like, okay, well, again, if I'm using a lion and elephant, I would say, okay, there's 321 lions, there's 876 elephants. That would be my count data. That would be the quantitative data. Okay, determine whether the data are qualitative or quantitative. If it's quantitative, is it discrete or continuous? And explain your reasoning. Okay, so A, we have zip codes. Now remember, zip code, while they have numbers, aren't actually imparting any sort of numeric information. They are labels more than anything, right? I could just as easily have switched all the zip codes in the US and they would work just as well. They were arbitrarily chosen because they're labels. That means that they're actually qualitative data. Okay, ages of dogs at a rescue facility. Okay, so age is a quantitative variable. Now, is it discrete or is it continuous? Now, a lot of people would think of it as discrete because we typically talk about age in terms of years. You're 17 years old, you're 18 years old, you're 19 years old. But age is actually continuous because technically when you went from 17 years old up to 18 years old, you actually had to go in between every possible value. So and that's really what kind of defines what continuous data is it is a line. So for example, in this age example, to get from 17 up to 18, at one point you were 17 and a half. At another point you were 17.25. At another point you were 17.125, and so on and so forth. And basically there's an infinite number of values between every two that you have to cross. Meaning that even though you're, when you're younger, you might say something like, oh, you're, 3 3/4, something like that. But technically, that's how age works. When you are aging, every moment you are a little bit older than you just were. Meaning that even though we just refer to ourselves as, I'm 17, I'm still 17, I'm still 17, but you are actually changing in your age. So age is continuous. Okay, capacities of commercial freezers. Okay, so capacity of commercial freezer is a volume. A volume is numeric because it describes the specific amount of volume that it has. And it is continuous because, again, for me to change between any volumes, it actually has to increase from every possible volume in between. Types of flowers. Okay, so types of flowers, this is a nominal variable, meaning that it is a name only. It's a label, meaning that this would be qualitative, right? So if I say this is a violet versus this is a sunflower, these are just labels that describe what type of flower it is. Okay, and distances of track events. So what this means is like 100-meter dash, 200, or 100-yard dash, 200-yard dash, stuff like that. These are quantitative because they are numbers, right? They have numeric meaning. A 200-meter dash is twice as far as a 100-meter dash. Now the question is it continuous or is it discrete? Now in this case, it's kind of hard to say because realistically the answer is continuous. Distance is continuous, right? So if I'm running 100 meters, then I've had to cross from 0 to 100. I've crossed every possible distance between there. But if you had, because the way it's written, distances of track events, if you had track events that went up in some discrete amount, 100 meter, 200 meter, 300 meter, 400 meter, 500 meter dash, then technically those would be discrete numbers because they are set jumps of 100 meters. But the answer is continuous for this one. It's talking about the distance. Okay, variable type. The STA 2023 grades for the academic year 2019 to 2020 are given below. So for the grade of A, we have 89 people who got an A. For B, we got 92 people. For C, we got 174. For D, we got 57. For F, we have 45. And for double F, we have 3. That's somebody who's caught cheating, honor code violation, something like that. So our qualitative data would be the grade, the letter, because that letter represents how well you did. It is not numeric, though. It does not have numeric meaning. The count would be our quantitative data. Now, I could change this problem, though, and I could make the grade quantitative by doing what? By changing it in terms of 0 to 100, or I could even do it by GPA, right? What is the grade that you get based on getting an A or a B? Like, okay, well, an A, let's say, is just a 4 point, let's say we didn't do the split, right? We'll say an A is 4.0, a B is 3.0, a C is 2.0, a D is 1.0, an F is 0, and a double F is still 0. So in this case, they have numeric meaning, right? But in this case, the problem we have here, we have grade in terms of letter, A, B, C, D, F, and double F. This means that those are qualitative. Okay, some more examples. Number of A's earned in a section of statistics with 238 students enrolled. This, of course, would be discrete because we're counting, right? How many A's are there? Did this student get an A? Yes. Okay, put a tally. 1, 2, 3, 4. It's a count, therefore it is discrete. The amount of rainfall for a city over the course of a week. So the amount of rainfall, again, rainfall would be a volume. That's how we measure rainfall. Volume is continuous because to go from one amount of volume to another amount of volume, you had to cross every possible amount of volume. Part 3, the number of cars that visit the drive-through in an hour. So this would be discrete, right? Because again, you're counting 1 car, 2 cars, 3 cars. The amount of gasoline pumped at the next 15 customers at the gas station. Okay, so this one's a little confusing for some people because we're not talking about the number of customers. We're not talking about the fact that we're counting customers, 1, 2, 3, 4, up to 15. We're saying the amount of gas that they pump, meaning that when we're accumulating the amount of gas, gas is a liquid, which means it's a volume, so it is actually continuous. Because person, 1 might have done 1.763 gallons, the next person does a different amount, and it gives us some final volume, which means we had to go from 0 up to that volume, hitting every volume in between, meaning that it's continuous. The length of time to complete a statistics exam. Okay, time is continuous. The height of a player on a basketball team. Height is also continuous, right? Anytime you want to think of continuous, think of, is there some point where if I went from this to that, I would have to cross every value in between? Or is it some sort of, does it have some set gap between them? Now, I will say for time and height, while they are continuous, we measure them in the real world in discrete fashion. For example, nobody says that they are 5'7.638", you know what I mean? Like no one says that. They would say like, oh, I'm 5'7", I'm 5'8", I'm 5'9". Or at most they might say I'm 5'7.5", something like that. Or you might even do it in inches, right? But in the end, we tend to talk about things in terms of discrete values, even though they're actually continuous. Same thing with time. We generally talk about time in terms of hour and minute, maybe in seconds, depending on context. Most people are not saying, oh, it's 5:34 and 36 seconds, 26 milliseconds, centiseconds, micro. We're not doing any sort of measurement like that. But time itself is continuous. It did go through all those times, even though we talk about it in terms of discrete. Okay, last one. Count of blue baseball caps worn by 10th grade students. So in this case, again, it is a count. That one's 1, 2, 3, 4. So therefore, it is discrete. So now we're going to do some quick check your understanding. In order to calculate the average score of 2,000 statistics students at USF, a sample of 70 students were interviewed and their test scores were recorded as an average of 76.32. In this study, the average of 76.32 is an example of what? So in this case, these are the scores of those 70 students we asked. So this would make it a descriptive statistic. Same question, but in this study, the 70 students are an example of what? So the 70 students are the people that we actually gathered the data for. They are our sample. They are a subset of those total 2,000 students. In the study, the 2,000 students were an example of what? Well, in this case, these are the population. These are the 2,000 statistics students that we're interested in. So they're actually our population. But to know what the parameter was, it would be the average test scores for all 2,000 students. So we'd be inferring that. One more, check your understanding. Are the below variables qualitative or quantitative? I'm going to go kind of quicker on this one. Weight is quantitative. Whether or not an individual went to sleep before 12 a.m. This would be qualitative because it'd simply be yes or no. Day a person was born. Now, this one you have to be careful with. When we say day a person was born, what we mean is Monday, Tuesday, Wednesday. These are labels, right? They are descriptive, but they do not really give us any sort of numerical meaning. That means it is qualitative. Distance from home to a mechanic, okay? So distance is quantitative, right? Because even whether you're doing it in meters, feet, miles, it is still numeric and it has some sort of numerical meaning. Whether an individual owns a laptop or not. So again, this is sort of a yes or no type thing. So this is qualitative. How many phone calls a person has made in the last week? This would be quantitative because it is a count, right? So it's a discrete number of how many calls did you make, and you would count them, 1, 2, 3, 4. The age of a person. So the age of a person is quantitative. Specifically, it is a continuous variable. The number of emails in a person's inbox. Again, this is count data, meaning that it is quantitative. That is it for this section. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.